All right, finding real roots of polynomial equations. What's another name for roots?
Square.
Nope. Zeros are another name for roots. Solutions to equations are another name for roots. Okay? The roots of an equation are just where it crosses the x-axis. And so the first thing we're going to do is we're actually going to go back and do some things that we were talking about yesterday even. Okay? Using factoring to solve equations. Okay? Well, we learned something yesterday that I told you how you can factor using your calculator, right? Okay, so let's start there. Put that into your y equals and tell me what the answer is. Okay, so your graph then, oops, doesn't look like that. Okay, so what do you get for zeros? Where does it cross the x-axis? Rachel? Okay, -3, 0, and 2. Okay, so it looks like this. Right? Okay, so my answer is, when I'm all done, is going to be the x equals 0, -3, and 2. Okay. Well, you know how to factor it from that, right?
Put the 0 in the first x.
Okay. We don't put the zeros in. We don't put 0 here, -3 there, and 2 there. No, we don't do that. All right. Now, we know that from these three zeros that we should have an x plus 3, and x minus 2, right?
Oh, yeah, that's what it was.
Okay. So now let's verify that and actually do it. Okay. So we know that when we factor, we're supposed to look for what? First thing we look for is what, 40? What?
Why is like x plus 3 and x minus 2, but not like x minus 3 and then x plus 2?
Because they're the opposites. Because when I put 2 in here for x, I get 0. When I put 3 in here for -3 in here for x, I get 0. Okay. All right, so what do we look for first? Okay, greatest common factor. All right, so what do they all have in common?
The 4.
Okay?
X to the 4th.
4x to the 4th. Okay? When I take out that 4x to the 4th, we get x squared plus x minus 6. So when I factor that, it almost looks like this then, doesn't it?
Almost.
We have x plus 3 and x minus 2 is the factor of x squared plus x minus 6. The only difference is that this needs to be 4x to the 4th power. Okay. There I factored it. By factoring it, I know I have a 0 at 0 from the first part. That gives me a 0 at 0, because the only way x to the 4th or 4x to the 4th can be equal to 0 is if x is 0. Right? Because 0 to the 4th is 0, and if I multiply that by 4, I get 0. Okay? So this first factor gives me a 0 at 0. Then I have a 0 at -3 and a 0 at +2. Okay? Did it by factoring. But you also were able to check it then by your graph. let's look at the,
The extra zeros.
what extra zero?
The top one. There's a negative 3 and a 2. How does that show where the 0 is?
This right here. There's three factors here. Okay, let's, don't forget that this means that this equals 0, or this equals 0, or this equals 0. Because to solve that equation, that means that each one of these factors is equal to 0. So you have to solve those equations. We just learned the shortcut of doing that by understanding that these are, when we have these factors, that the zeros are the opposites.
So anytime something's outside of the parentheses, it equals 0.
If there's an x there. Yep. All right, let's look at another one. So what do I have to do first here?
Everything.
Okay, everything has to be on the same side. So I need to subtract 6x squared first, or 26x squared first. Okay, and then when you write it, you need to make sure you write it in standard form. So x to the fourth minus 26x squared plus 25 equals 0. And this is just like that one in the homework. Okay, so if it looked like this, if I asked you to factor x squared minus 26x plus 25, what would you get? Okay, 25 and 1 add up to 26. So this would be x minus 25 and x minus 1. Okay. So the difference is, if this is to the fourth power and that's squared, I get the same thing, except it's going to be x squared minus 25 and x squared minus 1. Leela, can I factor that further? Okay, what would I get? Mm-hmm. Okay, so I've factored it completely, and so now my zeros are just the opposites. So x equals, and you could write it like this. There's a positive and a negative 5, positive and a negative 1. And if you graphed it, then you would see that it crossed the x-axis in 4 places. Those 4 numbers. 1, negative 1, 5, and negative 5. Students, so it's important that you pay attention. This thing we're going to talk about is called multiplicity. Sometimes a polynomial equation has a factor that appears more than once. And that just happened with what we did. This creates what's called a multiple root. So in this example here, we have a multiple root at x equals 0 because it's x to the fourth power. Because remember, I could write this as 4 times x times x times x times x. Okay? So there's actually 4 factors there. Okay, right? So it has a multiple root there that occurs 4 times because there's 4 factors. When we say x to the fourth, we're saying x times x times x times x. Same when we had this one here, and to check it out, we had x to the fourth down there also. So it has a multiple root. If we look at this example they've got here, okay? Because the first thing I can do is I can factor out x cubed. So because I have 3x cubed, that there's a root at 0, and it occurs 3 times because I have x, x, and x. Okay? So what we're going to look at is what's called multiplicity. And multiplicity tells you how many times a factor occurs. So in this case here, we have 3 factors. Okay? We have a factor 4x to the fourth, which that factor of x occurs 4 times. Then we have the factor x plus 3, which occurs once, and the factor of x minus 2, which occurs once. So how many times a factor occurs is the degree of the factor. Okay? What's the degree of this? What's the exponent up here? If there's no number there, then it's a 1. Okay? Here, this one occurs 4 times because the degree of it is 4. Okay? Down here, each of these occurs 1 time because the degree of each of those factors is 1. So when we're talking about multiplicity, we're talking about the degree of the factor. How many times does it occur? And this is how it looks when you graph it. Remember when we drew that first graph? We had, it looked like this, right? Okay. We had the degree here was 1. The degree over here is 1. But this one was to the fourth power. Okay. The degree here was 4. Take your calculator and graph x to the fourth power. Now, other than it opens up instead of down, doesn't that look like just that part of that graph? Okay, except it's upside down. Okay. So what happens is that whatever your degree is creates a certain look in the graph. Okay? And there's 3 different things that we're looking at. Okay? And they're shown here in this, well, they're not all shown here in this example. Okay? But we're looking at either we have 3 different things that could happen. We have a factor with degree of 1. And when I graph that, it's going to look just like a line. Okay? And we say in this case that it crosses the x-axis. If a factor has degree 1, then it's going to just cross the x-axis. It's going to look like a linear function. Okay? Like a line, y equals x plus 3. Okay? It'll just be a graph that looks like that. If the factor has a degree that is even, okay, even degree, 2, 4, 6, 8, 10, 12, and so on, then it's going to look like this. It touches the x-axis. Okay, so take your calculator. You just did x to the fourth, right? Okay, I want you to graph, does everybody know what x squared looks like? X squared looks just like that too, doesn't it? Okay, graph x to the 6th power. Okay, basically looks just like that, doesn't it? Okay, all even powered functions that when you graph them, they're going to look like that. X to the 8th will, x to the 10th, and so on. Okay, they all look that way. Okay, all right, so we've got factor of degree 1, it crosses the x-axis. We have factors that are degree is even, and it's going to touch the x-axis. And then we have factors that are odd but greater than 1. Okay, well, what's an odd number greater than 1? 3, 5, 7. Okay, so graph x cubed now. All right, and note what it does when it goes through the x-axis, when it crosses the x-axis. Okay, then do x to the 5th power. Okay. Looks just like it, right? Okay, so anytime that its factor is odd and greater than 1, then the graph is going to look like this. And when we see that, we're saying that, what does that do? What are we saying it does? Anybody know? Or what would you call that when the graph does that? You have a name for it?
Squiggle.
A squiggle, okay? Or a squiggle. All right, or we can say that it bends. Okay? So if you're looking at a graph and you see that the graph goes through the x-axis, it just goes right straight through it, then I know that the degree for that factor is 1. If it touches it and goes back the other way so that it looks like a quadratic or a 4th power, we know that it's going to be even. If it bends like this, all right, like x cubed, x to the 5th, and so on, then we know it's going to be an odd one greater than 1. So let's look at this one here. In this graph here, they have a root of -3, and look what the graph does. It touches the x-axis at -3. So that means that at -3, it has a multiplicity that's going to be even, okay, because it touches it. Over here at 0, it bends there. So we know that the degree there is going to be odd, but greater than 1. Now, I do know exactly what they will be, too, because in this problem, which I think it was this one that they did, okay, what's the degree of this whole problem here? What's the degree of it? 5th degree, right? Okay. So what happens is the multiplicity here, or the times those factors occur, must add up to 5. So then that means if this one's even and this one's odd greater than 1, that those two numbers for multiplicity have to add up to 5. So this one would have to be 2, and this one would have to be 3, because they have to add up to 5. Sure, right? Okay, let's look at it. We'll go with those. Okay, so we're going to graph these. So you got to use your calculator. Okay, so put that in your y equals. And then we're actually going to make a little chart to help us to be able to determine or write down the multiplicity. So there's your graph, right? Looks just like that. Now I have a table that's way too big, okay? Because here's what we're going to do. We're going to put in, because some of them, most of them will have more than just 1 0. But we're going to do it this way. We're going to make a table, and you can do this. You do it however you want, okay? But this is just an organized way to help you. I'm going to tell what the 0 is, what happens to it on the graph, and then I'm going to write down, okay, so this is the multiplicity. And then we're going to verify it when we're done. You're not going to need 3, 4 of them in this case, but okay. So where's the 0 at on this graph? Where's it at?
-2.
Okay, looks like -2, right? So I'm going to verify that. I'll hit trace, type in -2, and I get 0. Okay, so I just verified it, or I could go to the table and verify that -2 would equal 0. Okay. So I have a 0 at -2. Okay. What's the graph doing there? So the graph is going to do one of 3 things. Either it goes through, crosses the x-axis, it touches the x-axis and goes back the other way, or it bends. Those are the only 3 things that could happen. Goes through or crosses, touches, or bends. What does this one do? Okay, it bends. So if it bends, that means that the factors have to be odd greater than 1. Well, since the degree of this polynomial is 3, the best it can be is 3. Or it has to be 3. Okay. So what does that really mean? What that means then is that there's only one factor. If this is the 0, how do I write that 0 in factored form? What would I write it as? If I write it as a factor, okay, we just got done doing that, okay, it would be x plus 2, right? So it would be x plus 2. Well, and since the multiplicity is 3, that means the degree of it is 3. Okay? So graph this. Put that in your y2 and check to see if they're the same. What was wrong with that one? Press zoom 6. Because somebody changed these, they need to be on automatic. And I can change that to a 1 instead of a 10,000 or 100,000. That'll help you. Okay? It's the same thing, right? Okay, you can't tell it from the graph but there is no variation. But if you go to the table, they're exactly the same. So this only has 1 0. It bends at that 0, so that means that it has an odd multiplicity greater than 1, which it has to be 3 because the degree of the polynomial is 3. All right. So let's look at this one. Okay, put this one in your calculator. What? We're not using those other 2 lines in that table. We don't need them because we accomplished everything we needed. We listed the zeros and the multiplicity. We got it. hit zoom 6. Change your window. Hit clear right now. Hit clear to get rid of that. So what happens is you got 10 and 10. So you need negative 10 and 10. So I would just hit zoom 6, which is the standard viewing window. Just press zoom and 6. There you go. Okay. So first thing in my table, I'm going to list the zeros. Tell what the graph does, and then the multiplicity. All right, so where are the zeros? Okay, it looks like we have two of them. What are they? 1 and negative 3. Okay? So what does the graph do at 1? It's going to do one of those three things. Does it cross it, touch it, or bend?
Bend.
At 1, it crosses, okay? Well, if it crosses, there's only one option. It has to be equal to what? 1. Okay? It can only be 1, because if it crosses, that means it looks like a linear function there. So the degree of it has to be 1, so the multiplicity is 1. Okay? At negative 3, what does it do? Okay? It bends. All right? Well, here's the thing. The total of the multiplicities has to add up to 4 because the degree of the polynomial is 4. So if it bends at negative 3, well, the only way to get from 1 to 4 is to add what? 3 to it. So the multiplicity has to be 3. And that's it. Yes?
I didn't tell if it crosses.
Oops. Okay, you see how this moves when it comes there? Okay, that means it bends. But if it just goes right straight up, okay, then it just goes through it, straight through it. Okay? So that means then that if I asked you to factor this, you could. Because it means I would have x minus 1 to the first power and x plus 3 to the third power. Okay, so do letter A down here.